with an opportunity to continue to connect and engage with Lawrence. Also, in the typical Lawrence spirit, all of the speakers lined up for the Learning at Lawrence series are paying it forward by giving their time and talent to the institution and the programs that we all treasure. So with that, I want to thank you, Peter Levi, class of 2001, and Titus Seilheimer, class of 2000, for your willingness to be presenters in this new forum. They were scheduled to be giving a Bjorklunden seminar later this summer. So if you have any questions during the presentation, they are breaking up the presentation into 4 vignettes. Please submit those via the chat function, and we'll try to ask those after each vignette, and then we'll have time for more questions at the end of their presentation. So with that, now to our featured speakers, Peter and Titus.
Great, thanks, Shanna. My name is Peter Levi. As Shanna said, I'm Lawrence grad 2001, and I'm currently living in Iowa with my wonderful family. And here's my teaching assistant. She's going to help with a song in a minute. This is Phoebe, and I teach at Drake University. I really enjoyed the small class sizes and the ability to meet faculty and really push myself at Lawrence. And I'm so thankful I'm able to do that now at a small school here in Des Moines, Iowa, at Drake University in the Department of Environmental Science and Sustainability. And I'll talk a little bit more about my research later in the talk.
Hi, everybody. My name is Titus Seilheimer, class of 2000. I was a bio major and actually took aquatic ecology with Peter back then. So I am originally from New Auburn, Wisconsin and northwestern Wisconsin, but now I live in Manitowoc, Wisconsin, on the coast of Lake Michigan, which I'll be talking about. And I work for Wisconsin Sea Grant, which is a part of UW-Madison, and a network of programs throughout the country's coastal areas.
Great. So as I'm sharing my screen here, I'd say too that Titus and I, our commonality is taking Bart DeStasio's limnology class, and we give credit to Bart. He's really done a fantastic job, and there's a lot of scientists across the country and world now doing freshwater ecology research, all stemming from Lawrence and Bart's lab. So really exciting. As Shana said, what we wanted to do is talk to you a little bit about water today, something Titus and I are both passionate about and for different reasons. And we broke today's seminar into 4 vignettes. And so they do have some commonalities. Typically at a Bjorklunden seminar, we would talk about 5 different subjects, and we'd have a whole 3 hours rather than fitting 4 of these into 30, 35 minutes. So we provide our contact information throughout. And we do encourage you to bounce any questions to us via email anytime afterwards, and we're happy to answer those. And again, we'll pause after each of these vignettes if there's any immediate question regarding anything we just mentioned. And so I'm going to start out about water, then Titus will talk about fish, and then back to me about water quantity and quality, and then finally Titus thinking a little bit about our freshwater futures. So I wanted to start thinking about water, and that's where I brought my teaching assistant, Phoebe, along, because we all learn about water from an early age, as Phoebe has in her preschool already. So we wanted to sing the water cycle for you. Ready, Phoebe?
Yes.
Evaporation, condensation, precipitation, runoff. All right, fantastic. Thanks, Phoebe. And so we learn about water early on. We learn that it's a renewable resource, and it's very vital to our lives. Here I'm showing a figure from the USGS that demonstrates all the different ways that water is vital to our daily functioning as humans and as living organisms. And when another way to think about this is when NASA is looking for extraterrestrial life, that quote that I include there, "Follow the water," is what NASA uses to try to determine if other planets are habitable. That's because all of the biochemistry of life as we know it, that's the important caveat, as we know it, requires water. So it's this renewable resource that's always going through that cycle. So we have all the water on the planet that we're always gonna have. I always tell my students that it's fascinating to think about where all the water molecules in your glass of water, in your cup of tea, in your soda, whatever you're drinking have come from, and the story of all those water molecules in their past lives, right? From churning through the veins of dinosaurs to running through the Colorado River and forming these amazing landscapes that we see today on the planet. So that water just keeps on cycling, and now there's quite a bit of it in us. 60% of us, our bodies are water. So very important to life. And I think a lot about chemistry in my science. And so I'm not going to bore you with too much of that, but I think it's important to point out, why is water so important for life? These are just 3 reasons. It's a great solvent, so it can dissolve materials. So if we didn't have liquid water, we wouldn't have this material that provided that spark to life, those different amino acids and carbon molecules that were floating around in the big soup at the beginning after the formation of our solar system. Also, water is polar. So you can see I put a molecule up there, 2 hydrogens and an oxygen. So that means it has a slight positive charge and a slight negative charge. That allows water to have surface tension and hold on to different molecules and break them down as that great solvent that it is. And then finally, it's the element with the highest heat capacity, which means that it takes a lot of energy to increase the temperature of a kilogram of water. And so because of that, water can absorb a lot of heat, which is a good thing for ourselves and our ecosystems around us. The last little bit of chemistry that I like to show is this figure here, some common elements, common molecules that are light. So water is H2O, carbon dioxide is carbon with 2 oxygens, nitrogen is 2 nitrogen molecules, and ozone is 3 oxygen atoms forming that molecule. And the reason that I like to point this out is you can see that temperature bar at the top from absolute 0 at the coldest, negative 273 degrees Celsius, to 0 degrees Celsius in the middle. To make it even, I just went up to 273 degrees Celsius on the high end. And you can see that water, as we all know, water forms a solid at 0 degrees Celsius. It's a liquid from 0 to 100 degrees Celsius. And above 100 degrees Celsius, with of course, think of boiling water, above 100 degrees Celsius, water becomes a gas. So if we compare it to these other molecules made up of similarly light atoms like carbon dioxide, nitrogen, and ozone, you can see how unique water is. And this is just one of the amazing aspects of water that allowed for the evolution of life and demonstrates an importance to us. It's the only light molecule that, in fact, we experience all forms of it in our daily life, from gas to liquid to solid form. These other molecules, for instance, carbon dioxide doesn't even have a liquid form. Nitrogen and ozone do have liquid forms, but they are very, very cold. So think liquid nitrogen is what we freeze, deep freeze things to. And you can see that they don't even reach a solid phase until negative 193 degrees Celsius. So this just shows that water is a super unique molecule that allows for the evolution of life. Now, if we were to turn a little bit away from science and think more about the social and economic side of water before I turn it over to Titus, is when we think about water use in our country, we use a fair amount of water a day, 340 billion gallons. But there's a difference between water withdrawals and water that's actually consumed. And so if you look at these 2 pie charts here, we withdraw 340 billion gallons a day from groundwater or surface water, so streams, rivers, lakes. About 40% of that goes to thermal electric power, and about 40% of that goes to irrigation and livestock. Only about 12% goes to domestic and commercial use, which is what we would think of in our homes. So that's how much water is being drawn from rivers or groundwater every day. If we look at water consumption, though, we see the figure looks much different. So water consumption is when we withdraw water from a source and we do not return it back to the source. So you can see the amount of water consumed a day is 100 billion gallons. So it's about 2/7 of the amount withdrawn. And the majority of that goes to irrigation and livestock. And so, sorry, small children, quarantining. So 85% of the water that's consumed, so 85 billion gallons per day, is water that we irrigate over crops, and it does not go back to groundwater or surface water. Rather, it evapotranspirates into the atmosphere. So we're moving it from liquid phase to gaseous phase, which is that distinction between withdrawal and consumption. So we use a lot of water in the US. Some of it goes back to the source, especially with thermoelectric. Some of it does not go back to the same source, but rather changes forms. The last thing I'd want to point out on this slide, what I found fascinating when I learned this, is that only 1 to 3% of all the water that's treated at wastewater treatment facilities is actually physically consumed by us. The rest is put on our lawns, used for laundry, used in our showers, in our kitchens. And so we're spending a lot of money treating water to drinking water standards, and yet we are consuming very little of that. So that's something that comes into play and very important for the future sustainability and economics behind water. So to wrap up this first the shortest vignette, hopefully I kept it short, water, of course, is vital for life as we know it. It continually cycles in our planet. We get very little new water in from outer space, just a little bit. It has really unique properties, especially relative to other molecules that are made up of similarly light elements like carbon and nitrogen. And it's, of course, very vital for our daily lives, not only because we're made of it, but it drives our society and our economy.
I was going to say, Peter, I don't see any questions in the chat at this time, just so you know.
Great.
All right, then we'll jump into the next session. And what I'm going to talk about is some of the things that I do as a fisheries specialist with Wisconsin Sea Grant. And so as the title would kind of show, my specialty is fish. One of those projects that we've had kind of ongoing for a number of years is called Eat Wisconsin Fish. And it's really about raising awareness of the fish that are produced in Wisconsin. And I'll talk about those in a little more detail. But because I know this audience is, from all over the country and, who knows, potentially all over the world, it could also be eat local fish. So find out what your local fish is, what your local seafood is, and take a look at it and try to, support that. So next slide. So this is where I work. This is the system. I've been studying the Great Lakes for almost 20 years now, starting with some graduate work in Hamilton, Ontario, working on coastal wetlands. And now I work mainly on kind of the larger lake systems, including those commercial fisheries. Great Lakes are very important for fish production, and also for recreation, for recreational fishing, for charter fishing. They're also, very unique environment. This is a significant portion of the Earth's surface fresh water that's available. We have a lot of fresh water on Earth tied up as frozen ice, also a lot of groundwater. But in terms of surface water, which is fairly rare, this is a big portion of that. And to get an idea of the scale, if we took all that water, in the Great Lakes right here, we'd pour it out on the lower 48 states, it would be 9.5 feet deep. So, very, very large system, about 15,000 miles of coastline throughout both the US and Canadian side. And I guess my last fact before switching to the next slide is that half of that water, about 55%, is all in Lake Superior. So more than half of the Great Lakes water is in that single lake. It's a lot of water. So next, this just to get an idea of where we're at as a region. Just the U.S. side of the Great Lakes has over 4,500 miles of coastline, and what this graph is showing is that that is a significant amount of coast. It's like taking the Atlantic, plus the Gulf of Mexico and about half of the Pacific over there on the left side. That's how much coast we have in the Great Lakes. So we are definitely a coastal part of the country. And, you know, for me, working in a sea grant program, grant SEA, we don't have any seas or oceans here, but we do have a very much coastal community. Wisconsin has 820 miles of coastline. Some of our other coastal states like New Hampshire have about 18. So who is the coastal state there? So on to the next slide, and we'll start talking about, you know, kind of eat Wisconsin fish. What is the Wisconsin fish? And this is, you know, to start with, is the wild caught portion of that fishery. So Wisconsin and the Great Lakes do have, you know, historical and economically important commercial fisheries. This is Charlie Hendrickson, who, you know, is fishing. His son's on the boat with him. So it's a multi-generational operation. And he is catching lake whitefish with trap nets in southern Green Bay. And so, you know, what a trap net is, and we could talk, there's lots of different sort of historical perspectives on the fishery, different gear used. Charlie's using a trap net, which is a live entrapment gear, so he can sort the fish. And if you see that kind of white block of wood in his left hand, that is a measuring block for measuring those fish, because 17 inches is the legal size. So, you know, lots of, you know, sustainability it has a big part of this fishery to maintain the fishery for future use. We can go to the next portion of our Eat Wisconsin Fish is farm raised. So aquaculture, farm raised fish. The example there on the left is actually from Russian Waters Trout Farm, which is the largest rainbow trout farm in the state in Palmyra, kind of southern Kettle Moraine region. And, you know, this is another way that Wisconsin and really a lot different parts of the country are producing fish. And, you know, why that's important? Well, lower right picture there is Metcalf's in Madison, and they take, you know, a lot of pride in their sale of seafood, and, you know, focusing on some of that local seafood, knowing where it comes from, you know, keeping an eye on sustainability, because I think that the big question is, you know, why eat more seafood? And, you know, in a global perspective, Americans generally eat a lot less seafood than other countries do. And the graph in the upper right is looking at some of those Wisconsin produced fish, you know, wild caught and farm raised. And, you know, omega-3 fatty acids, you've probably heard about those. That's one of the benefits of eating seafood. It's high in omega-3s. That orange line towards the bottom is the recommended amount. And so you can see that most of our products coming out of the state are, you know, high in those omega-3s. So, you know, a good nutritional source. There's certainly some trade-offs to be aware of with things like legacy contaminants in the Great Lakes, PCBs, mercury, which is more of a global cycle. And so it's, you know, sort of about making informed choices, balancing out, you know, health versus some of those other risks. And if we go to the next slide, we'll see, you know, there's also sort of this historical, or, you know, the history into the future. And what we're looking at here is sort of global production of fish and seafood. So the dark blue is the wild caught fish. And, you know, this is global. So there's you know, the Great Lakes have a very small fishery relative to, you know, other states and other parts of the world. But I think the message here is that harvest is kind of leveled off. It's, you know, flat, but fairly sustainable, at least in some places in the world. But it's that light blue, it's that aquaculture and farm raised portion that, you know, that there is area for growth. You know, sustainability will mean wild caught kind of levels off, but, you know, there is sort of that future of what farm raised species might look like and how it can be done sustainably. And I think that for us in Wisconsin, that's, you know, that's definitely the farm raised fish are managed for, you know, water quality, what the discharge is, and whole systems like recirculating aquaculture can be done all indoors, very little water use. So I think there's this historical perspective as well. And if we go to the, kind of final slide in my section, I think it's not a plug. Part of my role as a Wisconsin Sea Grant is non-advocacy, but I can, point out that, the United States has a very, fairly strict, if you talk to commercial fishers, if you talk to fish farmers, too many regulations. But I think for us as consumers, we can, feel better about those regulations, and that, they have an eye for sort of sustainable management. And, in general, read the label, look for, different domestically produced seafood. And in general, you can feel fairly confident that it's well managed. The example here, Copper River salmon. So, very conscious efforts to brand, specific rivers in Alaska producing salmon and producing kind of premium products. And I think that is especially important today. So my last point is that COVID-19 has had a very large impact on, these different, both fish farms and commercial fishing industries. Most Americans eat seafood in restaurants, and a lot of the market for domestic seafood is directly to that restaurant business. And what we've seen with COVID-19 and coronavirus is that a lot of restaurants have been closed for very good safety reasons, but that has also affected some of these markets. So certainly something to think of. There's a lot of new opportunities to get fish and seafood directly from producers, and so that's something to think about when you're making your meal plan. It is Friday after all, so hopefully we've got some fish fries planned. So my summary slide at the end, just my key points here, and then it looks like a few questions have come in. So hopefully I've tempted you to want to learn more about the Great Lakes, to think about local fish and local seafood, supporting local businesses, looking at sources where seafood is coming from, and then in general the U.S. is pretty well managed. So if you don't want to figure out what a sustainability label is or where to find it, if it's a domestic seafood, it's in pretty good shape. So that is my section.
Great. We do have some questions in the chat now. And I think the first one actually is towards one of the slides in Peter's first section. It says, I have a question regarding the pie chart and regarding withdrawals. Can you explain again how the colors relate to the legend? Thermal withdrawals are a certain percentage, irrigation withdrawals at a certain percentage, but uses different percentages. So maybe Peter could explain that a little bit more.
Yeah, great. Sorry about that. We are trying to squeeze a lot in, and I get excited, so I might say things a little too quickly. So those pie charts show of all the 340 billion gallons of water withdrawn in a day, roughly 40% of that is for thermoelectric power, and roughly 40% of that is for agriculture and irrigation. So 40% of 340 is roughly 140 billion. And then that other chart demonstrates that about 85 billion gallons for the agriculture is actually, I'll go back to it quick. What it shows is that 41% of all our withdrawals are for irrigation and livestock. And that would be 41% of 340, again, is approximately 140 billion gallons a day. So then you can see water consumed is about 85% of now 100 billion. So it gets a little confusing thinking about water withdrawn versus water that is withdrawn and then moves on to a different form. Like, again, irrigation, there's a lot of evaporative loss of the water. Thermoelectric is so big on the withdrawals because of cooling towers. So oftentimes to generate power, there's a lot of heat generated. So water is pulled out of lakes, streams, or rivers, or even groundwater, and then that cold water is used to cool the plant, and then it's put back into the same river. So in that way, it's not consumed. water is pulled from a river and put back into the same river, which is why there's this big portion for thermoelectric in withdrawals, but not consumption. Only 3% of what is withdrawn for thermoelectric is consumed. So I hope that clarifies it a little bit.
Thank you. Our next question is for Titus. I was told at the time of pregnancy that PCBs land in the fatty parts of the bellies of the fish, and it's okay to eat the fish while pregnant as long as this fatty tissue is removed. Is this your take also?
Yeah, I mean, there's definitely there are very specific consumption advisories for different species. So I think that's important to consider. And yes, PCBs do, do kind of concentrate in those fatty areas. And I think one of the, I just this week saw a presentation from looking at increasing tribal consumption of fish. And, one of their recommendations was to skin those. You take the skin off, take the fat out, and then if you can grill or bake, you actually get more of those contaminants to kind of drip out as well. So, that's sort of the being informed and selecting the right species. A Great Lakes species might be higher in PCBs than, maybe a cod or a different, or even a farm-raised option, something like a rainbow trout or a farm-raised Atlantic salmon from the U.S. is going to have lower PCBs if those are the concern. So I think looking into those advisories for Wisconsin, I kind of go to the Department of Natural Resources and go to their fish consumption advisories for Lake Michigan and Lake Superior, because that's going to be a factor. You can actually eat more meals of lake whitefish from Lake Superior than you can Lake Michigan. So lots of considerations, and I think preparation also is an important part of that.
Well, continuing on, the next question is, what are some of the quality differentials between wild caught fish and the farm raised fish?
Yeah, I mean, there's quality, I think, is really comes down to how it's handled. If a wild caught fish can be of lower quality in terms of, kind of the flesh quality, if it's not handled well. So you want to, I think this is one of the areas where if you can buy directly from the fisher, if you can, kind of find out how they handle the fish, if it goes right into ice, if it stays cool, and, that's important. And you can find out the same things for farm raised fish as well. Handling is very important to the quality of the product that you might get down the road.
The next question, and I'm not sure you'll know the answer to this, but I live in Northern Illinois. Where can I purchase Wisconsin fish?
Yes, great question. That is the challenge even in Wisconsin. And one of our recommendations, you can certainly find, there are commercial fishers who will ship directly to your house. Shipping does get kind of pricey, but go to your local seafood counter and ask them for, Great Lakes fish, for Great Lakes whitefish. Maybe it's coming from Wisconsin. You could even ask for Wisconsin fish, and they may have a way to get that. If they don't have people asking for it, they're probably not going to get it. So, should we move on to the section, Peter? I know there's some Asian carp questions in there, and I can, that's a whole talk as well.
I was going to say, did you want to move on, or did you want to answer the couple questions that are left?
Titus, are you stewing? I can't see the questions because I'm sharing my screen.
Right.
Yes. So the next question is, how will Asian carp affect the Great Lakes, and do you have any recipes?
Yeah, that's definitely an issue. Potential big impacts, and that's why preventing big head silver carp from getting into the Great Lakes is important. I had a great walking taco made out of silver carp. One of the challenges with it, they're bony, and we as consumers in the U.S. don't like bony fish, and so if you grind it up, you grind those bones up, and it's they're filter feeders, very low contaminants. So certainly if you're looking for carp, Asian carp, especially big head and silver carp, give it a try. Northern Illinois might be easier to find that.
And let's just answer this one last question before we move on. And this is again for Titus. You say that U.S. fish is pretty well managed. And if we get fish in the U.S., that we're in pretty good shape. What about fish management in the U.S. is not so great? And what should we be aware of?
Yeah, so that, it's complex. I think when you start looking at individual species, individual stocks, some of those are in, the shape of the fish stocks or populations aren't as great. And, that might take a little more research, finding out where it comes from, and some of those, I think we default and say overfishing causes that, but, there's certainly environmental, what Peter's going to talk about next with water quality is, that becomes a fishery issue in some places. Climate changing, environmental, things are impacting stocks in addition to fisheries. So, that's where going to like Seafood Watch or the Monterey Bay Aquarium and, looking up the species, looking up where it's from and getting an idea how it's managed. A lot of times in the US, if the fishery is closed, you're not going to be able to get it anyway. So, it's really, and it could get even more complex. Like we can look at Great Lakes by lake, by fishing gear type, and that's not something you can do while you're standing in the grocery store, kind of freezer section and just says Lake Huron whitefish. So hopefully that at least gives you an idea of what I was talking about on the management side.
Great, thanks, Titus. And I will say that Titus knows a lot of Wisconsin fishermen himself, so he planned a field trip for our last Bjorklunden seminar up to a operation in Door County that a lot of our participants really enjoyed going and getting to see the inside scoop on it. So I want to talk a little bit about water quantity and quality. These are images of Lake Erie, which often one of our Great Lakes, the shallowest Great Lake that often has a lot of not nuisance algae blooming in it. So I mentioned at the top that water cycles continuously, which is really great for our planet, that we're always having more refreshed, so to speak. However, some areas have too little, some have too much, and some have water of very poor quality. So I wanted to touch on some of the water issues that touch on not only the environment and ecology, but also, again, society and economics. So to briefly go back to water withdrawals and thinking about how that varies across the country, this is a really fantastic figure that I enjoy breaking down. I'll first direct you to the bottom, looking from left to right. These are the 50 states plus several territories in geographic order from west to east. So you'll see Hawaii and Alaska, Oregon, Washington, California off on the left. And over on the right, you'll see Rhode Island, New Hampshire, Maine, Puerto Rico, and the US Virgin Islands. So what might jump out at you is you see a lot of that teal colored off to the left. So the western states, and you'll see that teal in the figure corresponds to irrigation. Then there's a pretty sharp transition to states where much more of water withdrawn is for thermoelectric power, right? So starting around Texas and then going through the Great Plains, there's Iowa, Missouri, Louisiana, Arkansas, Wisconsin, much more water withdrawn for thermoelectric in the eastern part of the United States than the western part of the United States. So of the 340 billion gallons that are withdrawn per day, we can see that it matters what state you're in based on where most of that water is going. And also it matters on population, right? So those tallest bars on the left is California, then we have Texas, then we have Florida and New York as you go down that stair step. But then you'll see some outliers, like next to California there is Idaho. You can see Idaho is the third greatest withdrawals in the country, much of that going to irrigation. Of course, think potatoes, like sandy soils. Water goes through sandy soils quickly, so they need to irrigate that a lot. Also, Arkansas pops up kind of right there in the middle, is quite high with a lot of irrigation as well. So there's a reason for this, and of course it has to do with science. Way back in 1878, John Wesley Powell, who was a geologist exploring the western US, realized that at the 100th meridian, if we think about latitude and longitude, right, the 100th meridian, there was a precipitation gradient. There was a major change in the ecology and the environment. And he noted this in 1878, and since then it's become, you know, common knowledge among hydrologists, scientists, farmers, that the 100th meridian marks this boundary between the half of our country that receives more than 20 inches of rain in a year and the half of our country that receives less than 20 inches of rain a year. And what's really neat is, of course, if you look at this satellite image, this is a composite image from NASA and the USGS, taking real satellite pictures of our country and piecing these smaller pictures together, you can see the 100th meridian from space, right? You can see where those darker greens transition to lighter greens to browns, right? So here in Iowa, the agriculture is 100% precipitation driven, but if you just go a little bit west to Nebraska, it is almost 100% irrigation driven because we're right at that natural boundary in precipitation. That's due to the rain shadow that the Rocky Mountains create. So they suck a lot of the moisture out of the air, and then there's a segment of dry air that forms our Great Plains. So this leads to this challenge between a really thirsty west and a water-rich east. That's really interesting. It plays out in the halls of Congress, and it's in our mentalities too. If you talk to someone from the East Coast or maybe Wisconsin, Michigan, Minnesota, we think of water conservation as protecting it, leave the lake alone, let the river flow freely. If you talk water conservation in Nebraska, Colorado, Nevada, California, water conservation there means put a dam on it and conserve that water so we can use it, right? So this meridian is almost in our psyche for whatever region we're from. And I did ask Shayna ahead of time what the geographic distribution of our participants were, and she said everywhere. So that's about as general as I can't get more specific on any region right now. So what does this mean in terms of water quantity? So if we look at this figure that I just put up, you can see that there's some smaller watersheds. This map is divided up by watersheds. You can see that there's areas that have water supply stress, especially those oranges, red, purple areas are areas that are annually under water stress. And as you can see in the box I include underneath, stress occurs when the demand for water exceeds 40% of available supply. This gives you an idea that much of the water stress or water scarcity in our country falls west of that 100th meridian, though you can see some, especially urban areas like Detroit, Chicago, even the little bit of the Milwaukee River watershed there is considered stressed as well for the different uses that water is used for around the Great Lakes. I'll note that what's interesting about Chicago is the reason that it's water stressed is because it sends water away from the Great Lakes, but that's a whole nother story too, engineering story. So on the one hand, many parts of our country is often thinking about drought and often thinking about water scarcity. On the other hand, a lot of our country is thinking often about too much water. This is a picture of the Niobrara River, which is in a beautiful river in Nebraska. And if you remember 2 Marches ago, so 2 Marches ago, we had a bomb cyclone hit the Great Plains. And then of course, this March, we had the cyclone of coronavirus hit our entire globe. But this bomb cyclone was a freak weather event where a lot of rain fell in a very short time period. Much of Nebraska was underwater. Interstate 29 is still in disrepair in some areas of the interstate. And so oftentimes we're dealing with too much water. And this gets into this concept of a 100-year flood. So around this time of major flooding last spring, here's a headline from NPR. When 1 in 100-year floods happen often, what should you call them? So this concept of a 100-year flood is just a statistical measure. As you can see in that other box I put on there, is that a 100-year flood is the magnitude or the quantity of water that has a 1% chance of occurring each year. So you can get 2 100-year floods in the same year. And so what should we start calling that if these are becoming more frequent and not just happening 1 in 100 years? Related to this is this idea that we don't live in a world anymore that we can predict as well as we could before. So here, this other line I have in this text box, flood categories are based on the previous record of events to calculate those statistics, but the patterns we've come to understand and rely on are shifting due to climate change. So a clear example is the Farmer's Almanac, right? The Farmer's Almanac was a resource that you could go to annually to have a projection of what the year might entail. But now we live in a world where it's hard to predict the weather in a week, let alone what the general pattern will be over seasons. And so this is an image of Houston after Hurricane Harvey hit it back in 2017. And to give you an idea of what is meant by this no analog world is that this is a map that was created by the National Oceanographic and Atmospheric Administration, NOAA. They needed to create a new color for that area of more than 40 inches of rain. The US had never experienced more than 40 inches of rain in a week. No region had ever experienced that until Hurricane Harvey hit the Gulf Coast in 2017. So NOAA had to come up with a new color scheme. Rather than going from purple to pink, they then added this light blue. So it's shocking to think about how the world is changing and how water quantity might yo-yo between a lot of scarcity versus just too much. What I also find really interesting is that a lot of states dealt with a lot of water last year. So what this figure is showing, again from NOAA, are all, I guess, the 48 continuous states. And this is the statewide precipitation ranks from the rain that fell from June 1st, 2018 to May 31st, 2019 for that 12-month period. NOAA has 124 years of record for water and for precipitation. And so the rank, that the number you see in each state is where that 12-month period ranks relative to all the other 123 year 12-month periods. So what jumps out at you is there's a lot of 124s on that map. So that means that 12-month period from June 2018 to May 2019 was the wettest year on record for a 124-year record. And for 31 of the states, that 12-month period of 2018 to 2019 was in the top 5% of the wettest years. Only Washington State experienced below average precipitation. And then there were a few states that were near their average of precipitation. So we're experiencing these extremes of too little water or too much water. And there's many challenges socially, economically, our infrastructure, et cetera. So that's what I wanted to touch on with water quantity. And what my research revolves around, Titus loves fish, I love nitrogen. I think about the molecules in water, which is why I think Titus and I make a great combination when we think about streams and rivers coming at it from and lakes from these different perspectives. So I'd be remiss if I didn't start a section on water quality with Flint, Michigan, which still is grappling with a major water quality crisis. This, of course, is very much an environmental justice issue, and environmental justice is a major thing that scientists are beginning to research more, and it's beginning to be more at the forefront of city administration and state administration, but we still have a long way to go, as we see with the other inequities that we're grappling with as a country right now. Environmental justice is definitely linked to social justice and racial justice. So this is a really important topic. Flint, Michigan, of course, experienced the tragedy of high lead concentrations in their water. There was a big government cover-up related to that. Data points were thrown out. People are now in jail. That's a topic for another discussion. But when we think about water quality, we all turn on the tap and we drink water. There are very few countries globally where you'd feel safe doing that. And ours is one of them. However, there are still some issues. So you can go onto the EPA's website and look at all the 114 different contaminants that it regulates, which is great. However, with that being said, there are more than 200 unregulated contaminants that are present in our water. So as you can see, these images below, pharmaceuticals and personal care products. So when you flush pills down the toilet, wastewater treatment facilities cannot remove those molecules. So that goes into the environment, and that potentially is, again, in your drinking water. That next image is of ecstasy. So illicit drugs can also be passed into the water. Boston Harbor has peaks of caffeine concentrations in the harbor around 11 a.m. every morning from all of the toilets that we're flushing at 7, 8, 9 a.m. Because, again, caffeine cannot be removed from water. And then that final image there is of plastic microbeads, which is a major issue. Without wanting to take away from our fourth vignette too much, this is my last little bit here, and what I spend my career thinking about is how what we do to the landscape affects water quality. So what runs off the landscape that affects it. This was an article that came out last year in the Wall Street Journal describing how the world's appetite is threatening the Mississippi River. So all of the agriculture here in the upper Midwest, you can see in this image, the first image of the United States is the bushels of corn that are produced by county. You can see Iowa, Illinois, Indiana, the vowel states of our Midwest are producing a lot of corn. And the bottom figure from USGS shows how much nitrogen fertilizer is applied to that landscape. So again, you can see that the corn belt is really clear on that map. So this appetite that the Wall Street Journal article references, as I have with my asterisks, is not an appetite for corn, but rather it's an appetite for pork, beef, chicken, and ethanol. What we raise here in Iowa, we say we feed the world in Iowa, but really we feed the animals that then feed the world. And so driving corn production are these secondary uses. Because of all that nitrogen on the landscape, of course, some of that nitrogen gets into our waterways, and just as it fertilizes plants on the land, it also fertilizes algae in water. And so every year we have a dead zone off the coast of Louisiana where the Mississippi River flows into the Atlantic Ocean. And 2 years ago, the dead zone was the largest ever, the size of New Jersey, which the New Jersey governor asked if they would stop using that analogy. So I apologize to New Jersey. And in that bottom figure there, you see a 30-year time window showing how much nitrate, the blue bars are how much nitrate is measured at the Mississippi River. The blue line is the size of the hypoxic zone for that year. So if you were to look, the ups and downs in the amount of nitrate that's making it to the Gulf of Mexico mirrors the up and down in the size of the hypoxic area. So the Midwest here is driving this low oxygen zone, and hypoxic areas are bad because shrimp cannot survive in low oxygen areas. So of course they need to scoot out of there, and they can't scoot quite as fast. Think of a shrimp trying to escape the New Jersey Turnpike in terms of space. It can't walk that fast to get to an area of water that has enough oxygen for it to survive. So this is a major issue. And what I'd leave with on that is that water varies a lot in its distribution. We're facing extreme conditions, not only in the US, but globally. A lot of climate refugees now are being forced to move due to water stress in their locations. India, Bangladesh, again, too much, too little. There are many chemicals that are not regulated in our drinking water, and those chemicals can lead to threats to human well-being, not only our livelihoods, but physically as well.
We have 5 questions in the chat. Did you just want to answer a couple before we move on to our last section? Okay, so let's get started. So when, sorry, I'm trying to read this one. So when Oregon says most water is withdrawn for irrigation, can I assume that is east of the Cascade Range based on west of the Cascade showing green on the map?
I would guess that in Oregon, much of the water withdrawn is definitely east of the Cascades. There's a lot of agriculture. And when you're having agriculture in the high desert, like Washington, Utah, Oregon, there's a lot of irrigation that's used. So yes, I would imagine that most of Oregon's water withdrawn.
And yeah, and that person has a couple other questions, but really, how can she find out more about the water in her local region?
That's a great question. That's the one thing that I try to tell people when they ask, what can I do about water issues? And I say, get to know your local watershed. If water falls on your house, on your lawn, on your head, where does it run off to? What's your local stream? Where does that stream flow? Are you in an area that gets its drinking water from groundwater or surface water? About 1/3 of our country gets its water from groundwater for drinking. 2/3 get it from surface water. So I encourage people to find out about their local waters, and much like Titus said about local fish, you know, the more that we learn and understand our local ecosystems, the more we'd want to protect them, or we know what the specific threats are to them.
So what can you tell us about the quality of well water overall in northeastern Wisconsin, and how often should wells be tested?
Northeastern Wisconsin, you have booming livestock up in Kewaunee County. So well water should be tested frequently. So water is regulated, but if you draw from a private well, of course, it sort of falls on you to get that tested and find out what's in it. So I definitely encourage people to take it to a local Department of Health, and they can run a sample for you. I think here in Iowa, it's about $20 for certain tests. It might be more for other tests, but it's important to know what's in your water. A lot of the things that we face here in the Midwest from agriculture and urban land use lead to chronic health issues. So nothing that's going to cause you to drink something and vomit right away, though Milwaukee did have that 1993 cryptosporidium outbreak, which is still the country's worst water-related health event that's ever happened in 1993 in Milwaukee. But these pollutants cause chronic health issues that will exacerbate over time rather than have that acute response of vomiting or not being able to drink it.
Next question, how might the recent rollback on clean water regulations by the Trump administration impact our clean water supply?
Yeah, so the Waters of the United States rule, there's a lot to that. This is why Titus and I love doing Bjorklunden seminars, so we can talk with people all day and at the meals. That the Waters of the United States rule did roll back protections on small headwaters, which of course connect to, that's the thing about watersheds, is that it's like our circulatory system, right? Our capillaries connect to our veins and our arteries connect to our capillaries. So if we regulate the large rivers, who's to protect the smaller headwaters that are now unregulated? So understanding what is happening on the landscape in your local watershed is important. The Trump rollback will have some negative effects on water quality, but what I always say is that drinking water utilities are required to meet the different regulations that EPA makes, but however, some of them are fined for not reaching those. So we're getting to know, look at every year, each water utility produces a confidence report. They're often kind of intimidating, but you could try to break that down, look at it, understand it, ask questions of the water utility if there's things that are beyond limits. Yeah, just becoming more informed, just like with fish and where it's from and such.
One last question for this section. What are the alternatives from using nitrogen as a fertilizer?
That's a great question, and we're doing a lot of research here in Iowa to figure it out. The one thing I'd say is, rather than having dumping fertilizer on the landscape in 1 or 2 goes, like fall fertilizer and then spring fertilizer, try to fertilize more often, so smaller amounts more often. Also, cover crops is a big thing. Cover crops will grow in the fall and tie up those nutrients, and then you just till them under. And so we're working with some farmers here around Des Moines, looking at how effective that is at holding nutrients on the landscape rather than having them run off during the spring flood events. And I guess we should ask Shayna, we're getting close, and Titus had some cool freshwater future slides.
We'll just keep rolling on.
Rolling, awesome, go Titus.
All right, so we're into the final section here, and we're gonna look a little to the future and talk about threats. But I think it's also it's easy to really get bogged down in the negative. That's what we tend to study, but there are positives looking at the future. So we'll get started on that. So, on withdrawals, and Peter talked about withdrawals, but specifically for the Great Lakes, these are just 3 recent stories. Upper right was just a commentary, I think, from an economist who suggested, hey, we've got record high water levels in the Great Lakes right now, causing damage. Why not sell that water? And it was kind of a thought experiment that had quite a bit of a negative response to it. And I think one of the challenges here, and for us, we are a water-rich region. We have a lot of water, but once you start moving that water outside of the basin, so it's high right now, high water levels, excess water, what happens when it's lower water level? And that becomes the concern. Lower right or lower left, not a Great Lakes example, but a proposal to fill rail cars with 500 million gallons of Minnesota groundwater and send it to the Southwest. So again, other places have less water, and they would like some of ours. And then just the middle example there from Waukesha. And so I would definitely, if this kind of story is of interest, Peter Annan wrote a book called Great Lakes Water Wars, and that was going to be kind of our required reading for our week in Bjorklunden, because it really covers a lot of interesting issues with water withdrawal in the Great Lakes. But Waukesha was kind of a fire point for diversions in the Great Lakes, because although the city is outside the watershed, the Great Lakes watershed, the county is on the border. And also as a consequence of sort of the way the topography is, the watershed boundary down in southern Wisconsin, eastern Wisconsin into Chicago, is really very close to Lake Michigan. And so in other parts of the state, you can go 100 miles or more and still be in the watershed. Down there, it's very close. So Waukesha had groundwater issues with radon, and went kind of back and forth for decades trying to get permission, which they eventually got, with the caveat that they would need to return their water that they used back to Lake Michigan. So some big complex issues there. We can move to the next potential threat, which again, I can talk about Asian carp for an hour. This is a boat with a whole load of, just like 2 hours worth of fishing on the Illinois River for bighead and silver carp. These commercial guys are contracted by the state to remove those. Millions of pounds have been removed from the Illinois River over the years. And so, that's part of the plan to keep these species out of the Great Lakes. And, definitely invasive species have impacted, the ecology of the Great Lakes, have had, trillions of dollars of impacts to economies in the US and the Great Lakes around the world. So it's definitely, something in the past, something happening now. And, what are those future species and what impacts can they have? The next threat that I have is the future climate. Ice fishing in Wisconsin, ice fishing on Milwaukee Harbor, like we're doing right here for brown trout. What is that going to be possible in the future? We're seeing warmer winters, we're seeing shifts in patterns of rainfall, in precipitation patterns, in intensity of rainfall. And if we move into the next, some of the initiatives. So WICI, or the Wisconsin Initiative on Climate Change and Impacts, sort of a collaboration between UW-Madison, the Wisconsin DNR, which was, reinvigorated recently by the Evers administration in Wisconsin, is really looking at, we have these global projections on the climate, but what do they actually mean? What are the impacts to us in the state? And looking at things like ice fishing, snowmobiling, maple syrup, cold water fish species like brook trout. What does warming climate mean for those? And it's sort of a transition into the next, the positive side. The Yahara 2070 project, which came out of the Center for Limnology at UW-Madison, the Yahara River chain is, Lake Mendota, Lake Winona, Wingra, and Kaganza, those Madison lakes and their watershed. And what they looked at was, taking these projections and building scenarios that had different, you can get a picture here, the 3 of the 4 options right here. What if we're not prepared for this future? Climate, population growth, changes in agriculture, all of those. What if we're not prepared? What would 2070 look like in the Madison area? There's also, focusing on technology. What if we shift our values? And then there's a governance scenario as well. So they take the science, but then they tell a story. And I think this is a really great way to sort of visualize, what these futures could look like. I know I work with a lot of managers, and we can move forward to the next slide. A lot of the managers, fisheries managers, they have year-to-year things they need to deal with right now. Climate change is, sort of something out there. Into the future, harder to deal with. So, I think for us in the Great Lakes, we're actually pretty well positioned. We have the, sort of existing cooperation to really meet a lot of these challenges. Things like the Great Lakes Water Quality Agreement, the Great Lakes Fishery Commission, Great Lakes Restoration Initiative. There's been a lot of investment in the Great Lakes. And also, by nature, we have 8 different states, we have 2 provinces, 2 countries, multiple tribes, and their, kind of sovereign governance as well. So, managing something like fisheries takes a lot of cooperation. I think we have that framework in place where, a lot of these agencies and non-governmental organizations are already working together. And I think that, is strength for us moving into the future. And, sort of our last piece is looking to the future and looking at the, the benefits to the economy of the Great Lakes, the blue economy. And that's sort of a growing, focusing on the economy of that fresh water. We have, you think of the Rust Belt and places like, historic steel mill country and, the loss of some of this large manufacturing. But looking at the future, this fresh water is going to be a really great resource for us in the region. And there's on the left side there, I think if we take the watershed of the Great Lakes and look at the GDP in that watershed, it would actually be the 3rd largest GDP in the world. So, really the Great Lakes region is already an economic powerhouse, and, a fairly diversified, a lot of different things happening. And we're also connected to the world, through the St. Lawrence Seaway. There are ways, that the Great Lakes are connected. And that, certainly, if we talk invasive species, that has been, also a negative for the ecology of the Great Lakes as well. And so, just our sort of final summary slide at the end here, I think looking to the future, protecting clean water, being aware of those invasive species and also keeping them out, and fresh water and cooperation are really going to be the future in the Great Lakes. And I think it's I'm not encouraging you to invest in the Great Lakes, but there's definitely I think some positives for the region.
We have one last question that was in the chat, and it says, do humans eat any of the harvested invasive species? Are they composed of or disposed of?
Yes, excellent. Yes and no. It really depends. Something like the silver and bighead carp, a lot of those are turned into fertilizer or disposed of, although some are, there's sort of these trade-offs between, if you create a market for an invasive species, then it becomes valuable. People build their business around it, and then what happens when it goes away? which is sort of, initially what we try to do with, invasive species control. But if you think of the Great Lakes, Pacific salmon, Chinook and coho salmon are not native to the Great Lakes, although they're, desirable species and we put them there for a reason. But other species like rainbow smelt, if you've ever been to a smelt fry, that is a non-native species that was accidentally introduced. So there's a whole range of, I think the Great Lakes, we're at about 190 different non-native species in the Great Lakes now. So, big changes there.
Well, I just want to thank Peter and Titus so much for sharing your time and talent with us today. And I loved your Bjorklunden slide with the 2 benches. And this is the perfect seminar sort of teaser for hopefully next summer at Bjorklunden. I want to thank everybody else for attending today. Join us next Friday, July 31st at 12 p.m. Central Time for our Learning at Lawrence Bjorklunden Presents event featuring Victoria Kononova. She's the Assistant Professor of Russian at Lawrence. Her presentation is entitled The Great Patriotic War, World War II Through Soviet Eyes. To learn more about the Learning at Lawrence series, check your email, follow us on Facebook at Lawrence University Alumni, or check out our website at lawrence.edu/alumni. So until next time, continue to learn, continue to lead, and continue to be the Laurentians that you are, and be the light. Thank you all for joining us today.
Thank you, everybody. We'll make sure Shanna has our slides if anybody wants them.